because I came to know about his coming in Ahmedabad because I have a friend in DIICT and they were doing a conference on information retrieval. And I was told that I don't know much about it. So I was told that he is considered to be one of the renowned and well-respected researcher in the area. And today when I went to library, Anil was telling me, if you have to talk about library search, he is the father of library search. I didn't know about that. So over to Stephen.
Thank you very much. Thank you for inviting me here, and thank you for the introduction. I'm certainly not the father of library research, because library research has been going on for a century or more. I'm not quite that old, but I have been working in information retrieval, which was part of library science, really, when I started. And now is usually regarded as part of computer science, although that's a bit misleading, because there's some very interesting work in this field going on in what used to be called library schools. Now in the West they tend to be called information schools, but they have a different take on search than the computer science people, so having both approaches is good. So what I'm going to talk about today, it's all history, but it's sort of up to web search, up to what web search systems do and how they work. But I'll start before the web, and I'll end up with a way which I think is quite useful, but is not usual, a way to think about what it is that web search engines do. So let's go back half a century. That takes me, well, actually, I started in this field, half a century ago, that's about right. So at that time, there were just the beginnings of some computer systems, but not very much. Mainly, the information retrieval environment was in libraries and printed indexes. So libraries have had and have ways and means to do information retrieval, to do search among documents, including some kinds of card catalogues, which were used to represent some kinds of classification schemes or subject headings. I'll talk a bit more about those in a minute. And then there were many kinds of printed index. So it's still usually the case that a textbook has an index in the back of it. So that kind of printed index. Phone directories, paper phone directories, which don't exist anymore. Dictionaries and encyclopedias. But so more important from the point of view of this talk, there were scientific abstracts journals. So printed journals containing abstracts of scientific papers, and they always had various information retrieval devices, classification schemes and indexes. And there were just beginning to be some forms of mechanization not involving computers. So mostly they involve punch cards. I'll say a bit more about that in a minute. Okay, so just a bit about how the world thought about, at least the library world, and a bit wider than that, thought about information retrieval in let's say, 1960s. So we'd have, many libraries would have a formal classification scheme, sometimes the same scheme in different libraries, and this is a tiny fragment of one of the classification schemes which is used in several libraries. So it has 9 general categories, including natural sciences and mathematics, and each category is subdivided. So there's a subdivision for mathematics, and a subdivision of that for geometry, and a subdivision of that for analytical geometries, and so on. So imagine a whole family tree of this stuff. and the books are classified in the scheme, and that is a mechanism for information retrieval. So if you want to search on a topic, you have to identify it in this scheme and go to that point in the library, that part of the shelves, and look there. Or maybe you go to that part of the catalogue and look there, and there's an interesting distinction there which I'll come to in a minute. In some parts of the world, including, for example, technical libraries, specialist libraries, so sometimes, for example, those in technical companies, like the pharmaceutical industry. So a pharmaceutical company would have a library of research and development materials, a substantial library, lots of material, and would have mechanisms for retrieving stuff from that material. And that might involve some system of subject headings or a thesaurus of some kind. And you might get in that thesaurus, which is a directory to all the subject headings, you might get a heading like analytical geometry. There's a broader term which is that, and there's a narrower term which is that. And you might have a list of those narrower terms for that heading, and you might be able to navigate around like that. And when you find the term that describes what you want, then you go to the index, which tells you what documents that applies to. There was when I'm talking about the 1960s, there was a relatively new idea at the time, which was called faceted classification, which owes its origin in part to a famous Indian librarian called Ranganathan, who was active in the, I think, 30s, 40s, 50s, something like that. He invented a fabulously elaborate scheme of which it was always said that the only way you could learn how to use it was to go to and sit at his feet for 6 months in true Guru tradition. Some of his ideas got into faceted classification, and I'll say a bit more about that in a minute. We had, at the time, various ways of thinking about all of this. So treat all of these alternative ways of doing classification as classification stroke indexing as controlled vocabularies. So terms like 500 with an explanation, or this term, are, if you like, form a vocabulary which has been set up, designed, constructed in its entirety by human beings in order to be systematic, to not have duplication, to not have synonyms, to be clear about what each term means. So all of these count as controlled vocabularies. And so the concomitant of that is that you have humans indexing things. So the way you locate a document of any kind in one of these schemes is a human looks at it and says, it belongs there, or it belongs in these places. So there was this other idea that was much discussed in the 40s, 50s, and 60s about how do you combine concepts. So supposing I'm interested in the history of geometry, in a formal hierarchical scheme, I have to decide where to start looking for it. So I might start looking in history, but that's unlikely. It's unlikely that the history section has history of geometry in it. I might look for a section of mathematics, a subdivision of mathematics called history, or I might go to the geometry section and look for history in that. It's not obvious how I should combine those two ideas. So maybe I can index something under both of those terms and invite the user to combine them at search time. So I'm still thinking in terms of a controlled vocabulary. So I've defined what history means somehow, and I've defined what geometry means somehow. But the user can say, I'm interested not just in one of those on its own, but in the combination of two. I used the word coordination at the top. That's the most important word. I've said post-coordination. There was a strong argument between what was called pre-coordination and post-coordination, but I'm not going to discuss that now. So it was a philosophical argument at the time. But faceted classification allows something like this. And actually, many of the ideas about how we might mechanize some form of information retrieval were aimed at exactly this problem. So people were using punch card systems. So if you have any history in that area, you may know that punch card systems were invented in the 1880s for the purpose of analyzing the US Census in 1890. Herman Hollerith, who invented the system, then started developing the idea to do all sorts of different kinds of data processing. And by the 1930s, this was big business. And the biggest company in this area was IBM. There were different ideas about how you might use punch cards for information retrieval, and some of them had been implemented, again, mostly in the high-tech companies of the time, the chemical industry, for example. One of the stimulating ideas in that direction was to allow this combination of concepts. Nowadays, we think of this combination as Boolean and logic. That is, you've got a set of things under history and a set of things under geometry, and you want the intersection of those two sets, which is the Boolean and. Come back to Boolean stuff in a minute. So, going back to printed indexes, the first serious use of computers in information retrieval was to generate or help to generate printed indexes. I don't know if, again, I don't know how much of this history you know, but there was a very famous 19th century scientist, inventor, engineer called Charles Babbage, who invented what we now regard as the precursor of the modern computer, the analytical engine. And it's interesting to understand his motivation, or one of his motivations. So he wanted to be able to do calculations in the same sense that we think of the origins of computers as being about calculation. Actually, that's not quite true, but never mind. Think about calculation. So Babbage wanted to be able to do calculations. In particular, so if I say log tables, does that mean anything to any of you? Some of you, not everybody. Okay, so if you're my age, you will have learnt at school how to calculate using log tables. Okay, and log tables have been around since the end of the 18th century. They've been compiled by hand. So in order to compile a set of log tables, you have to do a lot of calculations for every figure in the table. It's a huge operation. And people had done this and manually, okay, and they'd made mistakes. And it was known at the time of Babbage, it was well known, that many of the tables of logs that existed in the world were full of mistakes, or had many mistakes in them. These may have been important ones or not, it was not clear, but there were many mistakes. So Babbage thought, if we have a machine to do those calculations, then we can print out accurate log tables. So it was not about, as it were, you or I doing a calculation on his machine. It was about you or I having log tables which were accurate because they were produced by his machine. Okay? So the way he conceived this, the machine would actually not only do the calculation, but prepare the printing plates as well. This is a really advanced notion. I mean, it came in the world of newsprint in the 60s, 70s, something like that. 1960s, 70s, something like that. So it was 100 years in advance of that. But that was his idea. The machine would take it all the way through to the printing stage, so the mistakes could not be introduced at any stage. So printed index generation looks a bit like Babbage's idea. Again, starting in the 1960s, just in the 1950s, actually, people were thinking about generating printed indexes automatically by computer. There are many different versions of this, and you might do it from the kind of human assignment indexing that I've been talking about, where you get a human being to index a document with something like a faceted classification heading, and you get the computer to generate the different indexes from that. But the revolutionary idea emerged in the 1950s, due in part to an IBM man called Pete Loon, of taking part of the document itself, the text of the document, and generating an index from that. So Loon actually generated indexes from the titles of scientific papers. The basic idea of the index was that you took every significant word in the title, and that meant you had a list of words that were not significant, and any word that was not on that list you regard as significant. And you make an entry for this title under each of the significant words in it. Actually, sorry, it's not quite there. So that was quite a novel idea, and it started people thinking about using the text of documents for information retrieval. And as a general rule, the librarians were absolutely horrified. I mean, all the work that's gone into making a controlled vocabulary with all the effort of avoiding all the things that make natural language messy. They thought if you do it from natural language, it's bound to be, it can't possibly work. Not everybody thought that, but quite a lot of people thought that, and with some reason, because there's an awful lot of mess in natural language. So synonyms and different forms of the same word and phrases and all sorts of things that are hard to think about how to deal with. However, the scientific abstracts journals started going seriously into using computers for the printing process and for index production. So that was, on the whole, from librarian-assigned indexing journals, as I discussed. So that, as far as computers were concerned, that was the way to use computers in information retrieval, was to generate printed indexes. We suddenly realised, the world of information suddenly realised that that as a result of being printed from digitised copy, we had a digitised form of the entire scientific abstracts journal, and we could call this a database and do something with it directly. That sort of was just emerging in the 1960s. If you have a computer science idea of what a database is, I'm going to say why these databases were not exactly what you might think of as a database. So, first of all, they're flat. They only have one type of record. The record is a scientific abstract. Okay. There's some structure to the record. So it's structured into the author, the title, a source in the sense of which journal it appears in which volume, and which page, and which date. The abstract, okay, and maybe some human assigned indexing as well. But if you think of the title, and more particularly the abstract, it's a lump of unstructured text, which is not the sort of thing that computer science databases like at all. They can't conceive of what you would do with unstructured text, at least they couldn't in the 1960s. Nevertheless, there were lots of people thinking this might be good, it might be good to start searching these with computers. And if we do so, we want to search on anything that might be in there. So words and phrases, maybe human assigned indexing, so maybe words that have been part of a controlled vocabulary, or even codes, classification codes, but maybe also the free text versions of that, parts of that. So including the title and the abstract, searching for words in there. And allowing combination searching, so the kind of coordination that I talked about, Boolean and, but also the other Boolean operators as well. So, as a result of that kind of work, between the 70s and the 90s, there was quite a substantial business. At its height in the 90s, it's been partly, not entirely, killed off by the web, but it was a serious business in the 80s and 90s. And it worked like this. First of all, there was scientific abstracts, and then a number of other databases which were sort of similar in the sense that they contained lumps of unstructured text, business and news and other things. And some big companies acquired these databases and started searching them by computer offline. Just to give you an example of that, the National Library of Medicine in the States had its own database, which was, so it had its own scientific abstracts journal, indexing journal called Index Medicus, and started printing that with computers and generating a database which they then started searching. And when I was first starting in this field at the end of the 60s, if you were a medic wanting to do research on the research literature in medicine, you could write a letter a physical letter on paper to the National Library of Medicine in the States, and it would cross the Atlantic if you were in Britain and arrive there. And some experts in the National Library of Medicine would formulate a search using mainly the very good controlled indexing which the National Library of Medicine does for these things, which is called MESH. But also maybe natural language terms, would construct a search statement, run a search overnight, print it out on that old-fashioned fanfold sprocket whole paper, a thick wodge of it, and send it back to you over the Atlantic. So you could do that then. But what happened quite rapidly after that was that companies set up which acquired many of these databases and a search system and allowed you to search. And they started up with online searching dial-up, meaning that you have a telephone beside your computer and you telephone the computer in California which has these databases on it. And again, if you're in the UK, that's a transatlantic and transcontinental phone call. And when you hear the whistling at the other end, you stick your telephone into a device called an acoustic coupler, which is does some whistling of its own, and it becomes a data transmission channel at initially 110 bits per second, which is about 10 characters a second, in effect. So you have a printing terminal, so it's going ka-chunk, 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 and you can read it, but it's painful because you can read much faster than that. So you're waiting for it to produce the next word. So okay, that was sort of circa 1970. There were beginning to be faster ones then, and then there were developments in networks up to and including the internet at various stages before that, which allowed much faster access. And all the searching systems then, all the commercial searching systems, I should say, I'm going to come back in a minute, but all the commercial searching systems were Boolean, essentially. So in order to formulate a search, you have to do, this is what I spent quite a lot of the 80s and 90s teaching students how to construct a Boolean search. And it's quite an art, it's not entirely straightforward. Thinking about about language and about the way language might be used, and turning that into a Boolean combination of words that might find you what you want and nothing else. And it's really quite hard. These same companies that require many databases also often supplied software for internal systems for the other technical companies. So it started as a business in that period. Okay, so I will come back to an earlier period a bit later, but let's think about searching the web now. So the web comes along in 1988, was it, that it started, but then wasn't really going. But by 1990, very early 1990s, the web was there, okay? And people were beginning to think about how to search it. There are actually multiple claims to the first web search engine, but I'm going to stick my neck out with this one, partly because it was in Scotland. So there's a system called JumpStation, which started in 1993, which crawled the web and created a local database and allowed searching on. It's in the process of crawling the web, it only gathered titles and some kinds of headings, didn't gather the full text. And the searching was a sort of regular expression searching of an extreme simplicity. Nothing like ranking. Okay, so that's sort of proto-web search engine. Haven't really quite got there yet. But it wasn't very long before there were a lot more search engines. So in that period, those 2 years, there was a system called Web Crawler, which I believe was both the first full text indexing, that is, it crawled the entire text of each web page, and I believe also the first to give some kind of ranked search results, although they were not very good. There's a company called Lycos. I don't remember much about it technically, but it became a big commercial endeavor, but not in web search and in other things. There was Yahoo, which was actually, you might think of it as retrograde in the sense that it took a librarian approach. It actually tried to human index pages. It didn't use free text words at the time. And there was Alta Vista, which started, I think it was literally, it might have been 1996, I can't remember now. And that was the first good ranking system. It also was natural language search in the sense that it had what we now think of as standard search, a box into which you can type anything, and whatever you type, it will try to make some kind of sense of in search terms. Okay, so now let's go back again a little bit. So ranking, although the big commercial systems did not do ranking until very late, ranking was not invented for web search. It was actually invented much earlier in the area of research in information retrieval, which I was in. So the first ranking idea, the first published idea saying this is what we should do, we should rank documents for a user, I think was in 1960 by a couple of people, one of whom I later knew. So it was a research idea, but it started a whole area of research. So within a few years after that, there were many people, not many, but a number of people worldwide doing research into information retrieval, mostly using ranking ideas. So it became regarded as a norm. By, let's say, 1970, it was absolutely the norm. All researchers were using ranking systems. None of the commercial systems were, all the researchers were. And it just began, the commercial systems just began to do it in the 1990s, but very much later. So just to say a word about that, a personal word about that, I published my first ranking algorithm in 1976, so that's my kind of involvement in this. It was developed by the early web search engine people using a number of different sources of data. So The basic ideas that the researchers used were essentially word matching ideas. Some variants on that, but basically word matching and frequency information. On the whole, the databases that the experimenters were using then didn't have any structure at all. So we didn't have much more information to go on that. But the kinds of structure that you have in certain kinds of records, like if you have a title, it's clear that the title has special status in natural language terms, that the words in the title are, if you like, emphasized by being in the title. So using that field information might be useful. But there's another really important thing which occurs only in the web, which is this idea of anchor text. Now, let me, first of all, do you know what I mean? Does anyone not know what I mean by anchor text? Okay, a few people. Okay, so in a web page, web pages are typically linked to each other by clickable links. Okay, so if you see a usually blue, bit of in one web page, you know it's clickable onto to a second web page. So that text that's blue is sort of that's what's called the anchor text. It's associated with this link, and it's in some sense a description of this other page. It might be a very poor description. In fact, it might just say click here, but it might be something useful. Okay, it might say it might give a name, for example, and that's a person that you'll find out about on this page, and that's a really useful clue. So if you can take this piece of anchor text and associate it with the second page, then you've got more information about the second page. So for all the incoming links, you get the piece of anchor text and associate them with this page. So one of the things that does, for example, so I've got a home page which has got my name on it, obviously, Stephen Robertson. I'm quite often referred to as Steve Robertson. There's nothing on my page that says Steve Robertson. On the other hand, if someone else links to my page with the blue text being Steve Robertson, that's enough to say that this page is about someone called Steve Robertson, whom we don't know is the same as Stephen Robertson. So anchor text is actually extremely useful on the web. It's one of the great contributions. It's weird because going back to ideas about why natural language, why one might be dubious about using natural language for search, it applies in spades to anchor text. Anchor text is a mess, it's got all sorts of stuff in it. But nevertheless, it turns out to be extremely useful. And then there's this other idea which didn't emerge till Google. I'll tell a bit about that, which is this idea that you might be able to gather some evidence that certain pages are authoritative in some sense. So, to put it crudely, if there are a lot of links into one page, that might be evidence that it's a page which a lot of people think is a good page to go to. So, think about that as a minute. Okay, so I talked about AltaVista offering natural language searching in the sense of a query box into which you could type anything. They're also not invented for web search, so they've been around not quite as long as ranking, but for quite a while. So in the late 1970s, a lot of information retrieval researchers were thinking about how to help users, how to make interfaces that users would find easy to use and rewarding to use. And many of these ideas were associated with constructing Boolean searches, which, as I said, is a seriously difficult art. And if you present a user who doesn't know about it with an interface which expects Boolean operators, that's really quite hard. So, so the idea emerged that we might have a search box into which you could type anything, and we would have a machine extracting terms, words, if you like, maybe phrases, something like we've been doing in the other end, in the indexing stage, free text indexing. But possibly inferring Boolean operators. So if I type something like I said, history of geometry, then the system might be able to say, I want history and I want geometry and I want a Boolean and in between. Although actually it's really hard. It's really hard taking a natural language statement query and turning it into a coherent, proper Boolean statement which really works. And in particular, you can think of many instances where I would say I'm interested in cats and dogs, and it's clear that what I mean is cats or dogs in Boolean terms. So the interface that tries to decide whether to put in an and or an or, it might be confused at the point, and indeed was usually. So it became quite obvious fairly quickly that it would be better to use the kind of best match ranking systems which the rest of us researchers have been working on for years. So I mentioned a system called Okapi. It wasn't exactly my system. It was due to a colleague of mine called Stephen Walker, who worked in another institution in London in the early 80s, and then moved into my department a bit later, and we collaborated for many years. And I think that Okapi was the first system, actually, in about 1984 or something like that, to offer the user a text box of the kind I just described. So it was certainly around already. Again, it was taken up and developed by the web search engine people. So, when we talk about web search engines now, in most environments, Google is such a dominating presence that everybody thinks we're talking about Google, and that's true to some extent. I mean, I know that if you're in China, it's Baidu, and if you're in Russia, it's Yandex, and if you're in Japan, I don't know what it is. But nevertheless, Google's so dominant almost over the world. So Google came on board as a search engine in 1997 to 98. So in terms of my timeline earlier, that's a bit late. I mean, it took it a little while. So Brin and Page, who designed Google, they did make a very good system, I have to say. They implemented all the existing ideas somehow: crawling, anchor text gathering, word indexing, ranking. They had a really good user interface, and that was a very strong point about them. This sort of bare user interface without a lot of rubbish on it, which most of the others had. And they added this idea of an authority measure called PageRank. And then what they did was they went around saying, our system is much better than everybody else's because of PageRank. PageRank is our ranking algorithm. This is what we've done. And you can see why they did that. I mean, it was a reasonable business move. Because they'd invented PageRank. They hadn't invented any of the other things. They'd invented PageRank. So they had reason to be proud of it. I mean, it was a good thing. And it was one of the contributory factors to making their ranking algorithm quite good. But it was only a small factor, actually. My contention, that's what I was saying, my contention was that PageRank contributed a little to the effectiveness of ranking, did then, maybe less now, but very little compared to doing all of these things well, which they did. Okay, they did these things really well. So in comparison, for example, with Alta Vista and many of the other web search engines that were around at the time, they had a very efficient crawling mechanism. They were able to crawl more than most of the other web search engines. And since the web was growing by leaps and bounds at the time, that was really important. Crawling things quickly. They had a systematic, they actually started with a method of gathering links and I presume the associated anchor text They never say that, but I presume that. And they designed a very good word indexing and ranking algorithm, set of algorithms. The ranking included PageRank, but PageRank was a small component of that. Anyway, it was a good system, and for a variety of reasons, user interface, size of the database crawled, the effectiveness of the ranking, they came to dominate quite quickly. So, let's say, what have we, the rest of the world, learned as people who search, people who use web search engines, what have we learned about web search from Google and the rest? And I'm now thinking about, if you like, the 20 years from 1998 to now. Well, we've learned some rather strange things. We've learned that search is easy. That is more or less the case, that anyone can go up to a terminal or open their phone and type in 2 or 3, 1 or 2 natural language words into a search box and expect to get something reasonable. Okay? Few natural language words. Search is almost instantaneous. Type it in, and the time it takes for the stuff to come back depends only on your web connection, your internet connection. The result of that is that if it doesn't do something that we expect, if it doesn't do exactly what we want, we can iterate 5 times, 10 times, it doesn't matter, it's really quick. We can search over a huge range of different types of information, much more than any of the libraries we've ever seen. Different types of information don't even need to be able to spell, because the search engines usually can spell for us. This is a tongue-in-cheek, sorry. We hardly need to be able to think about it. We hardly need to think about it. Okay, we've learned all those things. That's, if you compare searching in 1990 with searching today, the situation is hugely different. If I wanted to do a search in 1990, I might have used one of those Boolean systems that I talked about if I could expect that my answer might be in one of these specialist databases. I might have gone to a library, a general library, and tried to use the classification scheme or the arrangement of books on the shelf. I might have used an encyclopedia. There are all sorts of things I might have used, all of which have now been replaced by web search. And that's been an extraordinary journey. It's been an extraordinary journey for me, absolutely. Okay, you can ask another question. What have the web search engines learned about search from us? So these web search engines have been observing the rest of us searching for 20 years. Well, they've learned how to answer many questions without actually understanding them. They don't understand them, they don't need to understand questions. Web search engines don't have understanding. They're not artificial intelligence. Well, they have some kinds of intelligence, you might say, but they don't have understanding. They've learned how to collect user behavior data. And this is one of the things that we worry about all the time now. They know things about us that we don't know about ourselves. And they've learned how to use it in many different ways. Again, they don't understand it. They don't know the human being at the other end of that, but they know how to make use of it. They know how to link things together. And they've learned that from the web pages and from the uses and from all sorts of other things without knowing what they mean. So, over 20 years, we've been learning from the search engines, and the search engines have been learning from us. And that's a feedback loop. And it's been extraordinary. It's been running, this loop has been running rapidly, round and round, for 20 years. And the present situation is the result of that feedback process. There are actually a couple of other feedback loops which I wanted to mention. So there's this business called search engine optimization, which you may have come across, which is about making sure that your website gets visitors. It's a cottage industry, quite different from the web search industry, which is a mammoth corporation industry. It's a cottage industry. There are lots of small advisors all over the world doing this. So one of the parts of that is trying to ensure that your site is ranked highly in results for many queries. This might be a good thing. So if I've got a website which is offering advice to sufferers from some particular form of cancer, let's say, and it's good advice, or it's potentially good advice, then you might think, okay, it's good that I should be trying to engineer my site so that people find it, okay? If, on the other hand, I'm offering, I don't know, pornography of some kind, you might say, well, actually, we don't really want lots of people coming to your site. The world might say that, somebody might say that. And there are things in between, which maybe include some kinds of advertising. But so this process is going on all the time, and some of it is good and some of it is bad and some of it is somewhere in between. Search engines are very happy to help things that they think are working. So if you do something, if you're running the medical advice website, Google and the others are quite happy that you should do some engineering to make sure that it comes out high. But they're trying very hard to work against some of the pernicious ones. They don't like the kind of engineering that will take any kind of search to a pornographic site. So the pornographers would love to make their sites like that. And the web search engines try to avoid that. So they're working on this, and this is another feedback loop. The search engine optimizers devise new methods of doing that, and the web search engines devise new methods of countering. Okay, so there's also this business model question. So when search engines started, there was no concept of a business model. Certainly, JumpStation didn't have a business model of any kind. Some of the early starters thought they had something of a business model, and it didn't really work. Google actually started without any business model. They didn't have advertising, paid advertising. They actually started showing paid advertisements in 2001, so 3 years after they started. As late as 2004, I was discussing this kind of thing with people, and they were saying, but Google doesn't have advertisements. They were actually very clever at hiding them. But they were showing them. The idea of pay per click was first put forward by a company in 1998, a company called GoTo.com, which became Overture, which was taken over by Yahoo. So it was actually adopted by Yahoo again in 2001, and Google got hold of the idea in 2002. Again, Google didn't invent it, but Google's made a great success of it. And then it became seriously profitable for web search engines. And so I'm sure you know a little bit about that advertisers bid for keywords, and if your query contains a keyword for which this advertiser has bid the most, that advertisement will be shown either at the side of your web search or at the top of your web search. And this has become a substantial business too. So we've got this notion, by the time advertisements come into search results, we've got this question about how you show, how the search engines have the problem about how you show advertisements as well as what are usually called organic search results, that is the real results of the search engine. Initially the idea was to put them at the side, on the right hand side of the screen, and leave the ranked list as it was. But this doesn't always make sense, because one of the things about web search is that you can use it for things for which advertisements are appropriate answers. So if you're looking for a new camera, it's not ridiculous to say advertisements for cameras should appear on that. So there's a question about what you should do with advertisements, and most of the web search engines now, if they think is the wrong word, if they categorize the search as being a product kind of search, they'll put advertisements right at the top of the ranked list. And maybe the search engine will show clearly which of the advertisements and which of the organic search results, and maybe it won't. So there's that distinction. Those are interesting questions for the search engine community, and there's a sort of consequential question, if you like. If you decide, if you're in the business either as a search engine or as an independent researcher like myself, of trying to evaluate how well a search engine is working, you typically put some queries to the search engine and see what results have come up, and classify them as relevant or not, as good or not. Should the advertisements be regarded as part of the relevance assessment? Another question. So, as I just said, many searches are, if you like, transactional in the sense that they seem to be intended to lead to a product or service, a purchase of something like that. So those look like things for which advertisements might be appropriate. And many websites are essentially advertisements, even if they come up in the other set of results too. So this is a quite tricky area. It's also another feedback loop, how the search engines deal with this and how the advertisers respond to how they deal with it. So we've got now 3 feedback loops. All of these have been running. I think the user search behavior loop is probably the most important, but all 3 have been running for quite a while now, and they've all seriously affected how search engines behave. Okay, so this is what I've just been saying. I'm sorry, I'm repeating myself. For the last 20 years or more, search engines have been developing, aided and abetted by these communities, the users who do the searching, website designers and advertisers. And they've been changing. The whole ecosystem, which this is, has been changing. Google is the biggest and most obvious player in this process, but not the only one by any means. So so the result of this is these web search engines, which look very different. They look very different from the first web search engines. They look even more different from anything you might think of from the library or scientific abstracts environment. So how would you think about what they do? Well, I would characterize it this way. First of all, they follow clues which they treat statistically. So everything they look at is a statistical clue of some kind. Words in queries and web pages, links between web pages, user actions, they're all clues. And they follow these clues in order to pursue goals. The search engines have goals. The goals are that they want you to come back. They want you to click through on both organic search results and on advertisements. They want you to click through on advertisements because that's their income stream. they want you to click through on organic search results because that will encourage you to come back. Okay, so they want you to do those things, and they want you to come back. Above all, they want you to come back, and they learn. So they are AI systems in that sense. They learn how to do these things in order to pursue these goals. They don't learn semantics, they don't learn meaning, they don't learn to understand the cognitive processes that users go through. They learn to do those things in order to pursue those goals. And they've learned extremely successfully, to an extraordinary degree that I find extraordinary. Okay, so to finish up, there's a science fiction author called James Blish who was writing in the 50s and 60s. And he wrote a series called Cities in Flight, of which the premise was that someone invented a method of space transport which allowed an entire city to become a spaceship. And there's a sort of economic process that he postulates, under which the Earth becomes economically depressed, and cities successfully go off into space in order to seek work. That idea is actually based on, if you're at all familiar with this, the Dust Bowl in the States in the 30s, which was immortalized in John Steinbeck's novel *The Grapes of Wrath*, when a whole area in the center of the States had suffered a severe drought, and all the small-scale farmers in the area were driven off because their homes and land were mortgaged to companies, so the companies called in the mortgages because they couldn't pay, and they were driven off. And they went to, many of them took Model T Fords, tiny, unreliable cars, and drove them as far west as California. So it was sort of modelled on that idea. But anyway, that's by the way. Okay. James Blish has this series based on this idea, and there's one book in the series which follows a particular character who finds himself accidentally he lives on Earth. He's a small-scale farmer. He finds himself accidentally on one of these spaceship cities, and it's about the rest of his life. And so this is written in 1962, and James Blish's idea about computers. He has an idea about computers. It's not quite what we would think of now, but the idea is that. So we're talking 1962, when the only computers were IBM machines the size of this room. So he has these computers which he calls the City Fathers. Okay, and the City Fathers look after various aspects of running the city. And one of the City Fathers is the librarian. And the librarian knows all about the entirety of recorded knowledge, recorded history. So this young lad who's finds himself accidentally on there and starts going through the education process on this city. And at some point he's asking, the way Blish describes it is like this: he goes to a booth of some kind and puts his card into a machine or something like that, and is allowed to access the city library, which is a machine, and asks a quite complicated question about sort of social history. And the librarian comes back initially with something that you might recognize as something like a Library of Congress subject heading, okay, but a little bit more complicated. Some kind of heading describing a specific topic with multiple parts to it, and then some text, and it's not clear whether the text is displayed on screen or read out orally, but anyway, there's some text in the book. And the text reads like a Wikipedia article, really like a Wikipedia article. It's extraordinary how he's anticipated that, even though the rest of it the rest of the context is so different. So he goes to this, he looks at this Wikipedia article, and then he realizes that the librarian has not returned his card after displaying this article. And he realizes that the librarian would like to offer him something else, okay, beyond the article that he first gave him. So the librarian, which spent its entire mechanical life substituting free association for thinking, had a related subject it would talk about if he liked. And so he says yes. Okay, and what turns out is that the related article is the answer to the question which he hadn't really dared ask. It's the answer to the question which he really wanted to ask but hadn't dared to. So my take home from this is that this is what search engines do. It's a development of the idea of free association, and I think that's a useful idea, because if you put a question to a search engine, you don't know how it's coming from that to what you see. Unlike the Boolean search systems, which I was teaching about 30 years ago, where you know exactly why it's come out, or you can work out exactly why your Boolean expression has produced this document. In the web search environment, you actually have very little idea why this document has come out top. Okay, the ranking algorithm that the search engine uses all sorts of features, including the words of your query, obviously, but so many other things that you can't see. Okay, the behaviour of other users, links that the associations that the web search engine can make between things from other sources which you can't see. So the relationship between your query and those things that come out at the top of the ranked list, the only way you can understand them is as a form of free association, I think. Okay. I'm very happy to answer questions or develop any idea. Sure.
So you have mentioned Boolean operators, how they link the keywords when you type in natural language search.
Yeah.
So how do they decide the order? So if I want to search history of teaching or teaching of history, so
that's a very good question. Okay, so if you say history and teaching,
so I'm not Boolean and, but they're assuming and.
If a Boolean and doesn't distinguish between those, okay, it does not distinguish. So if you were having this discussion in the 60s or in the 70s, you might say, well, we could construct a scheme in which that distinction would make sense. Okay, we could make that distinction. So actually, the distinction that I didn't describe between pre and post coordination, a pre-coordinate system actually. Faceted classification was a pre-coordinate system, and it would enable the indexer to say this is about the history of teaching and this other thing is about teaching of history, and they would appear in with different codes. So you could actually make that distinction. A pure Boolean system, well, okay, in a pure Boolean system you can't make that distinction. Actually, I'm being a bit unfair to Boolean systems because most of the Boolean systems had some extensions beyond Boolean, and in particular, they had to do with phrases in proximity. So you could say, I want documents which have the phrase history of teaching. Okay, and if they have that phrase, yeah.
That is actually restrictive.
That's probably too restrictive. Okay, so then you think, how can I make it? Well, there are various ways in Boolean terms. So you might say that I want history, or maybe you can think of other terms which are not synonyms but replace history next to or within 3 words of teaching or education or whatever. It's other words that relate to teaching. So you could do things like that with difficulty. Okay, that's exactly where the arcane art of Boolean searching comes in. It's actually the case that there are still people doing Boolean searching, and there are 2 areas where I know it's currently commonly used. One of them is the law, and the other is medicine. Okay, in the law, this is certainly true in the States. It may be true in the UK. I don't know in the rest of the world. If you have, let's say, a suit, let's say the government takes a company to court for something. Okay, the government will formally request through the courts the disclosure of a set of documents from the company. Okay, and the way the government will do this in the States is that the government lawyers will go into a corner and construct a Boolean statement 2 pages long, okay, saying we want documents that all the documents that are retrieved by this Boolean statement, okay. Then the defense lawyers have a look at it and say, don't be ridiculous, and they say, we propose a much more restricted Boolean statement, and they go into an argument, and the court decides in the end that this is the Boolean statement should be used. Before anybody sees any results from a Boolean search, they've decided what the Boolean statement should be, and then the company runs that, and all the resulting documents are delivered to the court. And it's a rather extraordinary process, because actually, as far as I'm concerned, good Boolean searching is an interactive process. You have to try things out to see what they're going to do, but there's no trial and error in that case. Medical one is slightly more sophisticated. There are people doing trying to gather evidence on sort of for evidence-based medicine about all the research that's been done on, let's say, the use of this drug in this condition. All the different kinds of research that might help in an evaluation of whether this should be used or not. And that tends to involve a complicated Boolean statement, but in that case, some interaction is normally involved. So Boolean search is alive and well in at least those 2 areas. There may be others, I don't know, but it's in those areas in which it really is complex, and it's really hard to do. If you're doing web search on the history of teaching, you probably, I don't know, I mean, you've probably done it. You may have done it. You get both. Okay, so getting a web search engine to separate those 2 is a little tricky. I have to say it's a slightly unusual problem. That is, most of the queries in the world don't look like that, don't have that problem. But it does happen, clearly it happens. I mean, I have to say, there are an awful lot of queries in the world that web search engines don't answer well. Many. But there are many more that they do answer well. But I mean, those are good examples. There was when I was learning about information retrieval at the end of the 60s, and the librarians were starting to argue about free text search, there was a particular example which they always used to say, free text search can't work because of this kind of problem, which was exactly your problem. But the problem was blind Venetian. Okay, so you have things called Venetian blinds. Okay, but you might also find a citizen of Venice who is blind. Okay, and as it happens, there was a Doge of Venice in the 14th century who was blind. Okay, However, if you do that search on Google these days, you'll get Venetian blinds. You won't get any blind Venetians. At least you'll have to work very hard to get those. So it's not a common problem, but it does happen. You're absolutely right, and it's the kind of problem that I've just explained.
As a librarian, I wanted to ask you,
Yeah.
why are discovery search engines more authentic and better than search engines?
Discovery search engines. In what sense? The legal discovery ones?
No, the scholarly search engines.
Oh, scholarly search engines. Okay. So scholarly search engines take advantage of the fact that they're dealing in a much more restricted range of documents. Okay. I mean, general web search engines have to deal with everything from a tiny page to as long as you like, and any degree of structure, any degree of editorial control. On the whole, scholarly search engines are working with scientific papers, that kind of thing. Is that what you meant? The scientific
If you
papers?
have a search engine across scholarly literature
Yeah, scholarly
versus discovery services for scholarly literature, the discovery services are better.
Okay, I'm not sure I know what you mean by discovery
So
service.
they have a unified index searching. So the
Right.
results are much more better, the ranking is much better.
What do you regard Google Scholar as? A search engine or a discovery?
Supposed to be a discovery, but it's a search engine.
Okay.
Whereas an EBSCO discovery or a summons is a discovery service which searches
Right.
scholarly.
Yeah, I'm obviously not. There's some systems I'm not familiar with. I mean, there are research communities which have gone into their own information retrieval in their own areas much more seriously. So, medicine is a good example with Index Medical, with National Library of Medicine. But there are cooperatives like high energy physics. There are a couple of. There's a database called Archive. Is that one of the ones you were thinking of? Yeah, Archive, which was set up by the high energy physics community. And one of the things that they did, the high energy physics researchers did, was to, if you like, collaboratively decide that they were going to support database creation, a good database creation system. So they voluntarily, authors in that field voluntarily contribute their material in a way which fits with that database. And that's a kind of development. It's really good. I mean, Archive, there are actually two databases in that area.
It's a repository.
Yeah, it's a repository in which the authors have a stake in making sure that it does it right. Okay, and that's worked very well for that area. In that respect, medicine doesn't work at all. Medical research is very uncollaborative, partly because so many big pharma companies are involved in it and are rivals. So it's a very uncollaborative area. So the only way that anyone can bring any audit of that is that organisation like the National Library of Medicine can try and do that. But I have to admit, it's not as successful at that as the high energy physics community. I'm afraid the high energy physics community is either the only one or one of the very few research communities that have managed to do that. Which is a shame.
I actually have a, this may sound a little tangential.
Sure. Tangential.
But so I'm going to talk about an example. So Facebook is a platform that stores or allows people to generate content and also search content.
Right.
So you can have search.
Yes.
So is there another feedback loop somewhere there where searchers can know about what other searchers are doing? So the idea that not just the search engine knows what searchers are doing, and not just searchers learning about how search engines work, but even between searchers, the behavior becomes more visible.
Right.
Is that another
It's
loop that's emerging?
Yeah, it sounds good and plausible. I mean, one of the ways in which, one of the obvious ways, it's obvious to searchers, in which the ordinary search engines use that is when they make queries suggestions. So if you start typing a query and there are a number of suggestions which come back immediately before you finish typing, those suggestions come from other users. And sometimes they're not right, and sometimes they're silly suggestions. Sometimes they include mistakes, actually, although the search engines try very hard to avoid that. But everything you see there is a query that quite a lot of other users have already touched. Okay, so in that sense, you become aware of things that other users have done without really knowing it. But that is what it is. I mean, I know that, for example, that my wife thinks that those suggestions are because they might give good results, but that's not really right. So the search engine doesn't know whether they give good results or not, and they sometimes don't. All the search engine knows is that the query you started to type is like these other ones which have been frequently typed before. So that is a small example of that. But I'm sure I'm actually unfamiliar. I hardly used Facebook search. I don't know. I'm unfamiliar with it. I don't know whether you can see anything, any aspect of what other searchers have done. I don't really know. But that sounds plausible. Yes.
If there is no other question, let's thank the speaker once again.